Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smartyurl.it/Jedi. My advice on how to pass actuarial exams is at smartyurl.it/pass. This video channel is at smartyurl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smartyurl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smartyurl.it/help-ISU actuary. Here's a problem for today for exam FM on financial mathematics. Consider a perpetuity which makes payments twice a year. The first year payments are 5 at time 0.5 years and 5 at time 1. Next year they are 10 at time 1.5 and 10 at time 2. And the third year the payments are 15 at time 2.5 and 15 at time 3 and so on. The annual interest rate is 8% nominal, convertible semi-annually. Find the present value of this perpetuity. And here's the solution. Recall that the present value of a standard increasing perpetuity due, so perpetuity being 1 at time 0, 2 at time 1, and so on, is 1 over d squared, where d is the discount rate per year. Let us note that the effective semi-annual interest rate is 4%, and the effective annual interest rate is I equal to 1 plus I upper 2 over 2 squared, so minus 1. So that's 1 plus 0.04 squared minus 1, and that's 8.16%. The present value of the payments at times 0.5, 1.5, 2.5, and so on is 1 over 1.04. That brings it back half a year, because 4% is the effective interest rate per half a year, times 5 over d squared. So the payments are 5, 10, 15, and so on. So it's a multiple of 5 of a standard increasing perpetuity due. And the standard increasing perpetuity due would start at time 1. This one starts at time 0.5. Perpetuity due. So this perpetuity due would start at time 0, and this one starts at time 0.5, so that's why it's reduced by a factor of 1 over 1.04. Where d is the discount rate corresponding to I, so d is equal to I over 1 plus I, and that's 0.0816 over 1.0816. That's approximately 7.5444%. And the present value of the payments at times 1, 2, 3, and so on is 1 over 1.04 squared times 5 over d squared. The same reasoning, it's a multiple of 5 of a standard perpetuity due, but starting at time 1, not at time 0. So we just need to bring it back by that, reduce it by a factor of 1 over 1.04 squared. Therefore, the total value of the perpetuity named in this problem is 1 over 1.04 times 5 over d squared plus 1 over 1.04 squared times 5 over d squared. And then we just plug in the values that we have, so the value of d, and we do the calculation. It comes out to be about 1,656.8628, and that's answer C. This problem was created by me, and the solution is mine. So it's copyrighted by me. All rights reserved. Reproduction in whole or in part without express written permission from the author is strictly prohibited.